Okay, so hello students. So welcome to our channel. So today we'll solve one more interesting problem of quantum mechanics which has been asked in CSIR June 2024. Fine. The question you can see on the screen that for a harmonic oscillator, Hamiltonian is given to us. Also a random state is given to us. Fine. And they have given that expectation value of x on this random state is this, beta under root h cut over m omega. Then we have to find out the value of beta. Fine. So let's try to solve this question. So you see, this expectation value is given to us. Fine. That means what we can do, we know that expectation value x, this is given to us psi x psi. Fine. So this cat notation is given to us. What we can do, we can write down this bra notation also for this one. So I can write this one also. This is nothing but 1 over under root 1 plus lambda square state 1 plus lambda. Now this will become e to the power minus iota phi, and this is 2. Fine. Now we can easily put these two values in this one. So what you will get now, that expectation value of x is nothing but, you can multiply this one and this one. So what you will get, 1 over 1 plus lambda square. Now you see what are the terms. First 1 with 1, so this will give you 1x1, right? Expectation value of x on state 1 plus 2 with 2. So what you will get, lambda into lambda, this is lambda square e to the power iota phi and e to the power minus iota phi. This will give you e to the power 0, that is 1, and then you will get 2x2. Fine. Plus, what is the next term? 1 with 2. So this will give you lambda e to the power minus iota phi 1x2. Similarly, lambda e to the power iota phi 2x1. This is the expectation value. Now see, what is this term? Expectation value of x on state 1. This 1 and 2 are the eigen state. It has been already given in the question. ये दोनों eigen state हैं. And we already know this thing, that expectation value of x on any eigen state, that is always 0. You know this thing. Expectation value of x on any eigen state is always 0 for the harmonic oscillator. Fine. So this thing we already know. So I can put this term as 0 and this term also 0. Now what about these? So one thing what I can do, one more thing, that I will put 1x2, this is exactly equals to 2x1. Now you can ask this thing, that why is it so? Because this 1 and 2 are the eigen state of harmonic oscillator, and we know that eigen state of harmonic oscillator is always a real wave function. तो रियल वेव फंक्शन में आप पहले x को 2 पे अप्लाई करिए, फिर 1 पे करिए, या फिर पहले x को 1 पे करिए या 2 पे करिए, देन so both answer will be same for the real wave function. If it is not a real wave function, then you cannot do this thing. Fine. So I'm putting these two equal. So now I can write it like this, that expectation value of x is 1 over 1 plus lambda square, and this will become again, you can write it like this. You can take this lambda common and you can take this term also common, 1x2, and inside the bracket you will see e to the power iota phi plus e to the power minus iota phi. Fine. Now what I can do? I can multiply by 2 and divided by 2. This whole term is nothing but the cos phi. So now you can write it like this. I'm just removing these two things. That expectation value of x is nothing but lambda over 1 plus lambda square, and this term 2 is also there, this 2, and this is nothing but cos phi 1x2. Let's suppose this is equation 1. So this is the expectation value. Now we have to only find out this term. So let's try to find out this term first. 1x2. I can write it like this. 1. What is x for the harmonic oscillator? We know this formula. X is nothing but h cut over 2m omega a plus a dagger, and 2 where you know a and a dagger both are the ladder operators. If you operate a on any nth state, this will give you under root n minus 1. If you operate a dagger on any nth state, this will give you under root n plus 1 n plus 1. Fine. So now you can write down. So this will become now under root h cut over 2m omega, and inside this 1a 2 plus 1 a dagger 2. Now see, when I operate a dagger on state 2, this will give you state 3. You see, n plus 1, next state. So this will give you 3 state, and 1 with 3, I can apply the orthogonality relation. 1 with 3, that is always 0, right? Something, this kind of thing we will get, 1 with 3, and that is always 0 from the orthogonality relation. So I can directly say that this term will give you 0. And what about this term? When I operate a on 2, this will give you 1 state lower. That means this give you 1. So 1 with 1, that is 1. So I can write it like this. H cut over 2m omega. So when you operate a on 2, what you will get? Under root n. So I can write this is under root 2, 1 with 1. And this is simply 1. So this will give you h cut over m omega. So put in equation 1. Put in 1. Expectation value of x is nothing but 2 lambda over 1 plus lambda square cos phi under root h cut over m omega. Now you can compare this expectation value with this one. So what is the value of beta? From here I can say that beta is nothing but 2 lambda over 1 plus lambda square cos phi. Fine. So this is a very simple question. Only important thing is the calculation, that how to operate a and a dagger operators and how you are handling these two terms, how you are making this cos phi. So this is the things which are the important in this question. Fine. So I hope you like this discussion. If you like the discussion, just write down in the comment section. Also like, share and subscribe our channel. Thank you so much.
अगर आपको ये वीडियो पसंद आया हो तो लाइक, कमेंट, शेयर एंड सब्सक्राइब आवर चैनल।